Alright guys, now I'm going to solve 2A using superposition. So let's go ahead and get a look at the voltages again for 2A. So I can, you know what, I have the paper right here, so I'm just going to write them straight down from that. So VA1 should equal 3.133 volts. VA2 should equal 2.133 volts. And VA3 should equal 0.133 volts. So that's what I'm looking for here with superposition, right? Let me get those windows off the screen. I don't know why those are showing up there. Alright, so basically superposition, right? We're going to go ahead and we know that my VA1 is going to be equal to VA1 from part 1 plus VA1 from part 2. And then I'll leave some space there to do that math. VA2 is going to be VA2 from part 1 plus VA2 from part 2. And VA3 is going to be VA3 from part 1 plus VA3 from part 2. And so I'm just going to, like I said, leave room there to do that math. Let me get this cursor off the screen, and now let me divide this page right here, and I'll split it right down the middle, and I'll do half on one, half on the other. Alright, so part 1 will be, we'll go with no voltage source. How about that? That first. And then part 2 will be no current source. Alright, so first let's get rid of my voltage source. I'm going to slide this up a little bit just so I have a little bit more room to work. You know what, here, that should be plenty. Alright, so with no voltage source, that means that I can short that voltage source, so my equivalent circuit will look something like this. Have a resistor, a short here, resistor there. Right, this is all good, and then up top I've got another resistor, and that's basically my equivalent circuit. Let me write some values. I've got 1.2 milliamps, I've got 5K, 3K, and then I've got 2K, and I've got 1K. And then let me label some voltages. So this is VA1. And now notice, with the battery gone, VA2 and VA3 become the same node. So this node here is VA2, and it's also VA3. But this is all for part 1. So let me note that that's VA1 from part 1. That's going to be here. VA2 from part 1 and VA3 from part 1, right? And then this will be my part 2. Okay. So this node is both of these voltages now because they're shorted. Alright, so what you may notice is that the 3K and the 5K are in parallel, right? They share two nodes. They share this node and they share this node. And then the 2K and the 1K are also in parallel. So even further, we can make another equivalent circuit that's just the 5K and the 3K in parallel, and then the 2K and the 1K in parallel. Alright? And this 2K in parallel with 1K is going to give me a 0.667K. And I don't know, 5 times 3 over 5 plus 3, I don't know, 15 over 8 in my head. So let me just go ahead and throw that in the calculator. 1.875K. So this is my equivalent circuit. I've got 1.2 milliamps still there. And note that this node now, like those two resistors, right, they became the 0.667K, and then these two became the 1.875K, but this node was preserved in the middle of the two equivalent resistors. So this is still VA2-1 and VA3-1, and then this node that's connected to the output of the current source is my VA1-1. Okay, and now it should be fairly simple to find the voltages, because we know the currents that flow. We know that it's just 1.2 times whatever 0.667K is. So let me pull this out. 1.2 times 0.667 gives me 0.8 volts. So that means that these are both 0.8 volts for this part. And then I just have to do the drop across the 1.875. So let me multiply 1.2 times 1.875, and that gives me 2.25 volts across this resistor, which means that VA1 is 2.25 plus 0.8, or 3.05 volts. Alright, so now for this part, I just solve VA11, it's equal to 3.05 volts. I found VA2 from part 1, which was 0.8 volts, and I found VA3 from part 1, also 0.8 volts. So we box all of those, right? And now I'll go ahead and write those in here. So my VA1 is going to be like VA11, which was 3.05, plus something that we haven't found yet that we're going to find in part 2. VA2 is 0.8 volts plus something we haven't found yet, and VA3 is 0.8 volts plus something we haven't found yet, right? So now we do part 2. Let me just separate these like by some little dividers so that we can get some clarity there. Alright, so now the second part is when I have no current source. This part might be a little bit more tricky. It's not terrible, but my equivalent circuit with no current source, basically I'm going to have my resistor here, and then I have an open, right, because I got rid of my current source. And then I got a resistor there, got a voltage source, another resistor, ground is down here, and then up here I've got a resistor, and that's my circuit. So that's 1K, 2K, 2 volts, 5K, and a 3K. And then let me go ahead and label my nodes again in red. This is VA3 part 2, this is VA1 from part 2, and this is VA2 from part 2. Alright, so now we need to find these voltages. Well, right off the bat, the only thing we know is that this node right here is 0 volts, right? We don't know anything else. But what we do know is that this right here is a loop. So I can make a loop equation for this loop, and I'll call this I1. And we also know that this up here is another loop. This down here, this is not a loop. No current will flow through there, no current will flow through here, so this loop might as well be gone. We might as well be looking at just this circuitry, which is a loop and a loop, right? So let me draw this current in this loop going this way. I'll draw my plus minuses, and what you'll notice is that this is I2. Only I2 flows through the 3K and the 5K, and only I1 flows through the 2K and the 1K. So when I make these equations, it's going to be very easy to solve because I don't have two equations, two knowns. I'm basically going to have just one equation in terms of I1 and another equation in terms of I2. So first, I'll start at the battery, and I'll make a loop equation for this loop right here. It's going to be plus 2 volts minus I1 times 2K, and then minus I1 times 1K. That's giving me 0. And so that's 2 volts is equal to I1 times 3K. And so I just divide by 3K, and I get that I1 is 0.667 milliamps. Alright, now I can do the same exact thing with the other loop and solve for I2. So let's go ahead and do that. 2, I start the battery, I go up by 2 volts, so I write plus 2 volts, and then I drop across the 5K by I2 times 5K. Same thing with the 3K, equals 0. And now I can group my like terms. 2 volts equals I2 times 8K. I divide by 8K on both sides, and I get that I2 is 0.25 milliamps. Alright? So now I've got my two currents, and I can find all my voltages, right? So I found I1 to be 0.667, okay? So if I go here, and I say, right, I1 is 0.667, that's dropping from 0 volts, right? and I know it's multiplied by 1K, so this is a 0.667 volt drop, which makes VA32, that's going to be, let me write it in red, it's going to be negative 0.667 volts. Right? Alright, and now I can find VA22, right? Because it's just that voltage plus 2 volts again. So VA22 is negative 0.667 volts plus 2 volts, which is going to be positive 1.333 volts. Alright? And now lastly, I know that I have I2 flowing through this 3K, so my drop across that 3K is going to be 0.25 milliamps, right, times 3K, which is going to be 0.75 volts. So I've got 0.75 volts dropped across this 3K, which means I need to take this voltage and add 0.75 to it. So what is negative 0.667 plus 0.75? It's 0.08 volts. Right? So now I've got my 3 voltages for this side. Let me write them out. I know VA1 for part 2 is 0.08 volts. I know VA2 for part 2 is, let's see, what did I get? I got 1.33 volts. And I got VA3 for part 2, which is negative 0.667 volts. Alright, so I can plug these into my equations up here for superposition, and then I'm done. So if I plug in VA1 for part 2, I get 0.08 volts, and if I add those, that gives me 3.13 volts, which checks out with what Spice got, right? 0.8 plus whatever I got for part 2, which is 1.33 volts, that gives me 2.13 volts, which again checks out with what Spice got over here. And then last but not least, I have a 0.8 plus negative 0.667 volts, which, let's put that in my calculator, minus 0.667, oops, sorry, 0.8 minus 0.667 gives me 0.133 volts, which again checks out with what Spice got. So that's 2A using superposition.